Hello. Okay, so in this, we're specifically going to be looking at how to store passwords specifically in the case when we have an application and we have a service level account. How are we saving the passwords? And in our previous particular video, we looked at brute forcing a particular masked dynamic masking, right? And one thing that you would see over here is the environment variables. And the best practice is that we specifically ignore this when we're implementing this or we're pushing this to GitHub, right? But the issue becomes if we're not using any sort of cloud services, right? We can't actually save the environment file within the actual environment itself, right? That would just make it irrelevant because anyone can come to the environment and copy the passwords. Yeah, there might be a way where we can set these values within the actual command prompt, right? And that's also not secure because if we're the current user, we can still view all of these, right? We can go to cmd, we can specifically write set, and then I think we just press enter, and you can see we have a lot of um, different variables that were are present within here. Okay, so in the first Python file, what we're doing is we're just taking the particular environment variables and we're running this. And as you can see, we get the particular access to database through the environment variables. This would potentially be fine if it's a cloud service where we can actually save the environment variables within the particular vault or any other cloud service providers functionality, right? The one thing that we can actually do, which is not that secure but it's better than just leaving it in environment variables, is using the key store, and that's specifically the Windows key store. And what we're doing over here, we're pushing all of the passwords there. What that means is the credential manager stores all of these passwords with a particular root key, and that root key is associated with your user. So if any other user tries to access this, they wouldn't be able to access your password, right? But this actually fails when we are the same user. Let's say if the password gets leaked and some threat actor accesses the user account and access the APIs, we can specifically get this, and then we can again run the API and see that we get access to the database. Okay, so then what's the last step, right? And that is using a vault. And what does that mean? So one way you can use a vault is to download one. And as you can see over here, I've downloaded HashiCorp Vault. And right now I'm running it in a dev environment, but this would just be similar to a production environment. The only difference is that dev is in memory and it has a lot of less hardening features that the production server has, right? But over here, the major thing that you would look in when you're looking at the vault file, right, is the role ID and the secret ID. Now, in a good practice would be to actually store this into the key manager that we're talking about, so that no one can just see these, because as soon as you have access to this, you can just call this and get the secrets. Although it's much harder to actually get the secrets from this, because obviously you would have some sort of expiry here and rotating codes. So basically it would be really hard for someone to just access the vault and get any sort of secrets. And the idea is that this way not all of your secrets get exposed if one of the APIs get compromised, right? And when we use this, we can see we also get access to the database, as well as the particular passwords that there were. And yeah, The only issue over here is that when we're running this in testing environment, obviously we get the unsealed keys as well as the root keys, which means with the root keys we can do whatever we want. We can configure the particular vault to do whatever, and that way we can actually get the tokens anyway. So yeah, make sure that you're not using any sort of dev environments for this.